Now we want to talk about dividing radicals. Right, that's the next thing that we want to do. And it's similar to multiplying radicals if it works nicely. So we're going to divide the radicands and divide the terms outside radical if they divide evenly. Right, so we're going to do that if they divide evenly. That's what we're going to do first. And then we'll look at, okay, what happens if they don't? Oops. So if you look in your textbook, here's an example. 4 cube root of 6 divided by 2 cube root of 3. So we'll just write that down. You can see what we're doing. Very simple example. This is not representative of most of the questions you're going to have to do. But if it works nicely, then we do it. So 4 cube root of 6, and we're going to divide by 2 cube root of 3. Okay? So 4 divided by 2, we divide those, and we divide the radicands. We divide 6 and 3, and we just leave the radical there. So we get 2 cube root of 2, and that's our answer. And just like with division, if you can, then you want to simplify. Okay, so we're going to say simplify if possible. And it may not be, and that's okay. But generally, this is only going to work if you have a single term, a monomial, in your denominator. And it's only going to work on top of that if everything that's in the numerator actually is divisible by your denominator. So it's a very rare case where that actually is going to happen. So we get into questions that ask us instead to rationalize the denominator. So what does that mean? Okay, so what it means is if it doesn't divide evenly. Okay, so if we don't then we rationalize the denominator. And you might say, what in the world does that mean? Well, what is a rational number? What is that? If you know that it's a number that is able to be written as a fraction. And essentially then it's not able to require or to include, not require, but to include a square root. You can't have a square or cube root or something that doesn't divide nicely in your denominator. So what we do is we get rid of the square root by squaring the bottom, by multiplying it by itself, and only the square root part. Okay? So if it's a single term, if it's a monomial, then we multiply the numerator and denominator by the radical. If it's a square root, and you only have to do this with square roots in terms of the curriculum. Okay, if it's a cube root or something else, you have to do something different, but we're just going to do it with square roots. All right, so that's what you do if it's a monomial. Okay, so what does that actually look like? I'll show you. So let's imagine, for example, that I have 5 square root of 3x, and I want to divide that by 2 root x. Okay, so root x cubed, let's say. All right, just to change it up a little bit. So this doesn't divide nicely. All right, 5 isn't divisible by 2, 3x is divisible by x cubed, but it's going to leave you with 3 over x squared, so that's not really that nice. So instead of doing that, what we do is we rewrite our equation and multiply it by the radical that is in the denominator. Okay, what is that going to do? Well, on the top, we're just going to end up with this, because x times x cubed is x to the 4th. We're multiplying the stuff under the square root. On the bottom, the square root of x cubed times the square root of x cubed just gives you x cubed. Okay, so it rationalizes it. Now there's no radical down there. And then, just like we do always, we simplify. So x to the 4th square rooted is x squared. Okay, and then you can divide the x's and end up here. So there's our rationalized denominator. Okay, you look in your textbook, there's an example there of 5 divided by 2 root 3. So simpler, another example, 5 divided by 2 root 3. The root is a 3, so we're going to multiply that on the top and bottom, which is effectively multiplying by 1. So we're not changing the question, because you might be wondering, well, why don't I just multiply it on the bottom? Well, you can't multiply just on the bottom. You have to multiply on the top and bottom, because then you're effectively multiplying by 1, which isn't changing the question. Okay, so that's why we do it. So we get 5 root 3, and then on the bottom, root 3 times root 3 is 3, and so this becomes 5 root 3 divided by 6, and that's our answer. So that's how we rationalize if it's a single term. Now what happens if it's a binomial? All right, so we'll say, okay, that's good. So if we want to do it with a binomial, meaning 2 terms on the bottom, then you have to multiply by the conjugate, all right? So you still multiply the numerator and denominator, but you're going to multiply it by the conjugate. It would help if I could spell. All right, so what is the conjugate? You might be wondering, like, that sounds great, but what's the conjugate? Well, I'll explain. We still want to square things, right? So if I have, so for example, let me just show you this by example as I explain it, because it will make sense, I think. Let's imagine I have 2 root 5 plus 3 root 2, okay? That's a binomial. What I want to do is I want to square them, because I want to get rid of this and I want to get rid of that, and the inverse operation of square rooting is to square it. So I want to square them, but I can't just go squared, because if I do that, it's going to give me a middle term. You guys remember, hopefully, that a plus b squared is a squared plus 2ab plus b squared. You remember your perfect squares, hopefully? You would have done earlier in the semester. So if I want to square them, what I have to do instead is I have to multiply by the conjugate being the other side, or the other piece to what is we know as a difference of squares. Because I effectively, if I just want to square both pieces of a binomial, I need to have a minus b times a plus b. So you'll notice right now I have a plus b. So the conjugate for this is going to be a, which is the first term, minus b, which is the second term. So what we're effectively doing is setting up a difference of squares. The simple way to remember what the conjugate is, it's the same terms with a different sign in the middle. And what it does for us is we can use this, that it just squares both terms. So instead of having to multiply them all out, I just square this term. So 2 squared is 4, root 5 squared is 5, and then minus 3 squared is 9 times 4. Or not 4, sorry, root 4. So 2. And that gives me 20 minus 18, and so it rationalizes the 2. And you can then, this is just, I'm just showing you what the conjugate is, so we're not doing it in terms of a denominator, but if you will end up with a numerator divided by this now instead of divided by that. So that's how you rationalize with a conjugate. A conjugate is just the other piece of a difference of squares so that you can end up with a squared minus b squared, okay? So we'll do an example and see how it works. So 5 root 3 divided by 4 minus root 6. So you have 5 root 3, and then you're dividing by 4 minus root 6, okay? So if we want to rationalize this, we need to multiply by the conjugate of the denominator, which is going to be 4 plus root 6, and 4 plus root 6. Okay, and again, the effect of that is on the bottom, you just are squaring the term. So 4 squared is 16, and root 6 squared is 6. So we're going to get this. On the top, you go 4 times 5 root 3, which is 20 root 3, just using the stuff we just did with the multiplying. So we're multiplying the 4 by the 5. And this doesn't have a root, so it doesn't get multiplied by anything, but the root 3 stays. Here, root 6 times root 3 is root 18, so we get 5 root 18. Okay, then we try to simplify. So 16 minus 6, that's 10. 20 root 3 isn't going to simplify, but root 18 is root 9 times 2. So that's going to give me 20 root 3 plus 15 root 2 divided by 10, because 9 square rooted is 3, and 3 times 5 is 15. And then we can actually divide everything by 5. So we're going to get 4 root 3 plus 3 root 2 all divided by 2. And that's our answer. So we've rationalized the denominator. Okay? So rationalizing the denominator is just you're multiplying by the conjugate, and the conjugate is just the same two things with an opposite sign in the middle. All right? And that, again, the effect of it is that instead of having a square root on the bottom, you now have a rational number. That's why it's called rationalizing the denominator. You have a nice number, for lack of a better term. You have a number that's not a square root. So you can practice more of those. There are more examples if you scroll down in your textbook. There's a bunch of examples on the next page, I believe, on page 288. We scroll up to the top of the page there, or I guess they're at the very bottom of 287. There's 4 examples where you have to rationalize. Okay, and they're all square roots except for this one, the cube root. We're not gonna. You don't have to know how to do that. Okay, so you don't need to worry about that. And then there's some your turn questions after that, and I think we'll leave it there because that's the concept. But I would like you to try them. Try the first ones that give you the answers. You can kind of follow those, and then try the ones that say your turn. And if they're all good, then you know how to rationalize denominators. And then, of course, there are exercises after that. There's a bunch of exercises that are multiplying and dividing. All right, so you can try some of those as well.